Oresme understood, based on the idea that speed is proportional to time, that the average speed is half the final speed, or that formula we saw earlier, v bar is equal to 1/2 v sub f. How might one come to this conclusion from a graph? Well, I already have the graph we looked at in the last example here. Or maybe one way to look at this is if I identify this as some process, and I'm going to put a little point right here that represents my, like, the final point of this process. And in that sense, on this graph, I think the vertical coordinate for this spot right here, that really represents that final velocity v sub f. And if we're thinking about the average velocity, it might make intuitive sense that since this thing started at 0, went all the way up to v sub f, it was increasing its speed steadily. In other words, acceleration was constant throughout. That maybe the average velocity would be somewhere halfway. So a line like this. An argument that maybe starts to get a little bit into the calculus arena, which again, officially this is not a calculus-based physics class, and I've been accused sometimes of mentioning calculus and therefore making it a calculus class. That's not what I'm doing. I'm just mentioning it, right? But one way of looking at this is to say, like, well, if I did have something moving at constant velocity, right, velocity times time would be change in position. But in this picture, like if I said, hey, let's look at this right here. And I guess I kind of overstepped my axis a little bit here, but final time is somewhere like down there. But if instead of like speeding up, what if I just started at some average speed and continued that way? Then the total distance would be average velocity times time, would correspond to the area in this box. But if I kind of said, well, hey, I'm going to take the area of this triangle over here and move it over here, I'd have the same area for these two. And that would mean the same amount of displacement. And it turns out everything works perfectly if this is exactly halfway. If it's not halfway, those two areas wouldn't really be equal. So that's kind of a way of coming to that conclusion. So let me go and look at the answer here. It brings us that graph again, and then there is the v bar, in other words, the average. And again, I'm a little bit arguing intuitively here that it makes sense that it should be halfway up, and there it is in relation to final velocity.